Hello, welcome to today's video. The last time we discussed and talked about divisibility rules as is one of the concepts that we explored to understand or as prerequisite for our understanding of sets. Today we'll continue with the divisibility rule 6, 7, 8, 9, and 10, and we'll add it to our previous knowledge. If you have not watched the first video on our explanation of concepts on divisibility rules 2, 3, 4, and 5, please do well to watch the first video because all these prerequisites will be needful in understanding what our topic sets. So we are on prerequisites 2, and let's get to our whiteboard and finish up with our divisibility rules. So we'll start with divisibility by 6. We know that the number 6 is uh, the number 6 contains 2 and 3. So 6 is equal to 2 times 3. So any number that we are going to get should be divisible by 2 and 3 at the same time before we consider number divisible by 6. I will take 12 as an example. So 12 is equal to let's check if 12 is divisible by 6. So to check if 12 is divisible by 6, we should be able to identify if it's divisible by 2 at the same time and 3 at the same time. First, let's do 2. So from our previous video, we said that a number is divisible by 2 if the last digit of a number is an even number or is an even digit. So in this case, it is 2 and 2 is an even digit. In the previous video, we listed all the even digits. So you do well to go and watch that video on that. Yes, so 2 is it ends with an even digit, so obviously it's divisible by 2. Now let's check if it's divisible by 3. So we say that 2 is qualified. Now it's left with 3. For divisible by 3, we say that you have to sum the digits of the number. So 1 plus 2. 1 plus 2 is giving us 3. This 1 plus 2, we sum the digits to get a number. So the result that you get, you see that the result is 3. And that result is divisible by 3. Since it's divisible by 3, then it qualifies. So then the number 12 is also qualified to be divisible by 2, by 3. Since this number is divisible by 2 and 3, therefore the number qualifies to be divisible by 6. Let's take number 16. If number 16 is divisible by 6, so we say 6 contains 2 times 3. So we need to check if 2 qualifies. So 2 qualifies because the number that we are focusing on divisible is ending with an even digit. So if it's an even digit, then it qualifies to be divisible by 2. But let's check if it's divisible by 3. For divisible by 3, you have to sum the digits. So 16, that's 1 plus 6, we get 7. 3 cannot enter 7. Therefore, it doesn't qualify to be divisible by 3. Since that it's qualified to be divisible by 6, but not by 3, not the 2. Therefore, it does not qualify to be divisible by 6. That's for divisible by 6. Simple as that. We are going to make a lot of reference to the first video, like concepts from there. So if you haven't watched or you don't know about that, please go and watch that one. Let's check divisible by 7. If let's assume you have a number ABC, like example, it can be 1, 2, 3. So let's check if a number is divisible by 3. So to check if a number is divisible by 7, what you do is that you take the last digit of the number, which is C, right? You multiply by 2. So C times 2. So let's assume you get an answer called D. The answer that we get after multiplying, the answer we get is D. So we take the remaining ones. So what you do is that you cut it off. You cut the C off now from the family of the ABC. So now you bring it up here. So AB minus the answer that you get from the multiplying by 2. So let's say you get D. So if you do AB minus D, you are going to get an answer. Then you check that answer. If that answer is a multiple of 7 or divisible by 7, then it qualifies. If it's not, then it doesn't qualify. If you are still not sure and the answer that you get is like another multiple numbers that you are so confused about, you can still continue, repeat the process. You can repeat the process until you are confident. So let's do like an example with 21. An obvious example is 21. So let's see if 21 is divisible by 7. Before that, you have to know that the possible answer that you're supposed to get is a multiple of 7 or 0. The answer can be 0 or 7 or multiple of it, or multiple of 7. So that's what the answer should be. The magnitude of the answer should be. So 21. Let's see. You take the last digit, which is 1. We multiply by 2, then you get 2. Now we strip it off. We remove the 1 from the family. Then we bring 2 here, minus this 2 is from here, minus this 2 that we get from here. So that's 2. The answer will be 0. So you see the answer is 0, and then it's called, and our final answer is 0. Therefore, the number 21 is divisible by 7. Let's use our original example, 123. So if we have 123, we take the last digit, which is 3. We take it out, we multiply by 2. Somewhere on our jotter we get 6. Now we remove the 3. Right, now we take the remaining guys, which is 12. 12 comes here, minus the answer that we got from the multiplication, which is 6. 12 minus 6 gives you 6. And 7 cannot enter 6. 7 and 6 are unrelated. So what happened is that it does not qualify. So the number 123 is not divisible by 7. Let me take another example called the number 42. 42, for example. So I will take the last digit, 2 times 2, which is 4. Then I will now remove it and focus on only this guy. So 4 minus what I have here is 4. So I bring it here, 4. 4 minus 4 is 0. Let's do for a bigger number, 127. 127 3. Yeah. Let's do for a bigger number like this. Let's check if this number is divisible by 7. So I'll take the last digit, which is 1273. So that's 3 times 2, give me 6. So now I'll now remove that 3 from there, focus on this guy. So now I'll bring this guy, 127 minus the answer that I get here, which is 6. 6 gives me 121. Now this answer too, I'm not sure of it, so I need to repeat the process with 121. So I'll now have 121. So we take the last digit of this 121, that's 1 times 2, we get 2. Now we now strip it again, then we have 12 minus the answer that I get here, which is 2. 2 divided by this is now what? 10. And we know 10 is not divisible by 7. Therefore, the original number that we have is not divisible by 7. In case you get a multiple of 7 or you get 0 as the final answer, then you have to um, admit it. But then someone say, okay, let's try to 10. Let's continue with 10 because someone say he's not sure. So you are going to have 1 0, right? 1 0. Then we take the 0. 0 times 2 to 0. We strip it off. So you have 1 minus this 1 here minus the result that we get 0. We get 1. The final answer is 1. We say the final answer should be 0 or a multiple of 7. So this still does not qualify. Yeah, that's divisible by 7. Now let's clear the board and continue with divisible by 8. For divisibility by 8, we know 8 contains is 2 times 4. We know divisibility by 2 and divisibility by 4. That's what to apply. That's to apply. So that's a smart way of handling it. Divisible by 2 and divisible by 4. If they both satisfy the particular number, then we go ahead. So let's see this. Let's look at this. Or the main condition for 8, if a number is divisible by 8, then three digits, the last 3 digits of the number should be divisible by 8. So you have give you 1, 1, 2, 4, 3. You are going to focus on the last 3 digits. If the last 3 digits is divisible by 8, yeah, so there are this number, or you can just use the condition of 2 and 4, like how we did for 2 by 3 thing that we did earlier. So you can just continue with 2 and 4. Yeah, that's about 8. So already this number is not end with an even number because If you want to focus on 2, focus on the last digit should be an even number. So there already 2 does not qualify. So since 2 does not qualify, then everything fails. Therefore, this number is not divisible by 8. So someone would say 1124. If what you have 1124, you see that the last, you have to focus on the last digit because you are checking for divisibility by 8. So for by 8, so you know that 8 is equal to 2 by 4. So let's see if 2 enter the number. 2 enters the number because it's ending with uh, an even digit. Yeah. Now we have to check if it's divisible by 4. For divisible by 4, we say the last 2 digits should be divisible by 4. For divisibility by 4, we say the last 2 digits divisible by 4. If you don't understand, it's on on the previous video. So you look at that. So 24, 8, 4 can enter. So since 2 and 4 can enter this number, this last 3 digits of the number, then therefore the entire number is divisible by 8. Simple as that. We apply the same principle as we learned earlier. The, the next one is divisible by 9. Divisibility by 9, we know that 9 contains 3 by 3, right? So we say, in the case of 3, what we were doing is that we sum the digits. Over here too, for divisible by 9, we also sum all digits of the number. So if answer equals to 9 or multiple of 9, then it qualifies. Otherwise, it doesn't. So an example, let's take 18. Let's say if 18 is divisible by 9, what we say that we sum all digits of the number, which is 1 plus 8. 1 plus 8 is 9. So we see that the answer is 9. The answer is 9, which is 9 here. The answer is 9. So it qualifies. Let's say 127. 127 is 1 plus 2 plus 7, which is 10. 10 is not. Therefore, 127 is not. Let's try 27. 27 is same as 2 plus 7, which is 9. So it qualifies. So let's try a bigger number, 1341. Just an example, I don't know. So I'll just add some the degree 1 plus 3 plus 4 plus 1, which is 4 plus 4. That's 8 and 9. Okay, it qualifies. This number qualifies. Qualifies to be an even number. 27143. Another example from anywhere. So it's 2 plus 7 plus 1 plus 4 plus 3. So 2 plus 7, that's 9, 10. 10 plus 7, that's 17. If you are still not sure of the answer here for this one, you repeat the process. Then you go to 1 plus 7. 1 plus 7 is equal to 8. Therefore, the number is not divisible by 9. Yes, that's how to check for divisibility by 9. The last one is divisibility by 8. No, sorry, divisibility by 10. So for divisibility by 10, we have to just check that the last digit should be 0. Should be 0. So the last digit of the number should be 0. The last digit of the number should be 0. That's how to check for divisibility by 10. The last digit of this, if the 0 doesn't end the number, so 50 ends with 0, so it's divisible by 10. 27 is not ending with 0, so it's not divisible by 10. Yeah, that's how to check for the divisibility by 10. For 10, it's very simple. Just check if the number is divisible by 10 or not. So in our next video, we'll continue with all the remaining. I'm hoping we'll be doing prime factorization. We'll be doing prime factorization there. Now that we understand this divisible, we are going to do prime factorization over there. So prime factorization will be very helpful. It will help us a lot. Yeah, so we understood prime numbers from the previous video. Today we understand the divisibility rule, and prime factorization is the next prerequisite that we need to explore on our journey to understanding sets. Thank you very much, and I hope you understand the concepts and test them.
Do not miss the next concepts. Why don't you subscribe to keep notified of new videos and concepts?